Welcome to section 6.1. We're going to talk about confidence intervals as they relate to means. We've done confidence intervals with proportions, and now we're going to start stepping into means. And there's just some changes as we get into this stuff, and I've been discussing, we're going to kind of run the same processes over with some different distributions. And so we've been dealing a lot with a normal distribution and a standard normal distribution. And so today we start the student's t distribution. And it is actually quite similar to the normal distribution. Just the major differences are we don't usually use it with large data sets, even though we can. The larger our sample size is, the more it really mirrors the normal distribution. But it's the student's t distribution. And we use it oftentimes when we don't know the population standard deviation. So we'll be estimating the standard deviation using the standard deviation of the sample. And when we do that, we bring in another variable. Instead of sample size, we talk more about the degrees of freedom. And so the degrees of freedom here are the sample size minus 1 for this thing. So these can be done with tables, but we're going to be using Excel, and we'll use the t-inverse or the t-inverse two-tail functions in Excel to find critical values similar to the normal standard inverse function, knowing our alpha and some things like that. Now, there are some different ways to find confidence intervals, and I'm going to start with kind of linking it back to the process we were using for finding confidence intervals with populations. So we used to have the margin of error is equal to z alpha over 2 sigma over the square root of n, and this is really the standard error. Now we have the margin of error is a t alpha over 2, which is a t-score, a standard t-distribution score instead of a normal score, and then we use the standard deviation of the sample divided by the square root of n instead of the standard deviation of the population. Because we're trying to make a confidence interval that contains the mean, we take x bar and we subtract the margin of error for the low side, and x bar plus the margin of error for the high side, or the upper and lower limits of where we're confident are where whatever confidence we choose, we're that confident that our true mean for our population is in there. So we have a little stem sentence here kind of for the what it means. We'll be making confidence intervals, but what they mean is actually the important part. So once we find a confidence interval, and it's based on a confidence that we're given and an alpha and all that fun stuff, we can estimate with whatever confidence, say 95% confidence, that the true population mean is between whatever values we have. Anyway, so we'll get into a little bit of that, but I just wanted to kind of refresh on the process. A lot of similar things. We'll call this a critical value. This is standard error, but just things have changed in terms of what we're using and the variables at play. So getting some questions to do. The first one from 6.1, oftentimes, just like before, we're just going to work with finding out what the critical value is. That's that t alpha over 2, and I'll bring up Excel for doing that here. So for this question, find a confidence level, for a confidence level of 99%, what is the sample, with a sample size of 18, find the critical value. It's easy for me to say. So confidence level, a lot of times we can abbreviate that with confidence level, and I'm going to put it as 0.99 because I'm going to want to find the alpha. And I want alpha in terms of a decimal here. Our sample size is 18. And so our degrees of freedom is 1 less than our sample size. So I take our sample size and subtract 1. And I'll show my work here. Maybe. Uh-oh. I thought I kind of clicked out of the cell. Okay. It's usually not this difficult, but right now it is. But we'll be okay. Oh no, I just did it again. Are you losing all confidence yet? Too late? Okay. So, this is not supposed to be the difficult part. But here it is, showing the work. I'm using the cells here just to kind of make life easier for me. You saw how much easier it was. So alpha is equal to 1 minus our confidence level. And I'm going to just click on those, and then hopefully I'll easily copy and paste this. But you never really know. So there's kind of the work. And the t-distribution, similar to our normal distribution, and I'll just kind of draw the same kind of curve. It's a little bit rough. But essentially we have a t-distribution here. We'll have our confidence level 99% in the middle, and our little alpha over 2 is here and here. And these are our alpha over 2s. So the little area right here is going to be well, I haven't found the alpha over 2 here. I've got to do that. We take this total error and divide by 2. And that error is our alpha still. The alpha doesn't change. So we have our t-distribution, which may or may not look like this. This is a good enough estimate. We have the error split into 2 parts. The 99% is in the middle. So that's our t alpha over 2. Or this is going to help us find our t alpha over 2, which I'm going to just call the critical value, because that's what we used with the other distribution. And kind of trying to keep the process the same. I'll equal to, and if I start going t, notice I've got t-distribution, two-tail, t-inverse, two-tail. I'm going to just go with t-inverse. This mirrors most closely what we did with the normal standard inverse. And I'll do 1 minus alpha over 2, because that gives me all this probability to the left of this score, and that will give me a positive t-score here. Now the degrees of freedom are next, and you'll notice here we have t-inverse. It asks us for the probability, then the degrees of freedom. Sort of the nice part about using Excel is it gets us this. Now, here is our work. This is our t alpha over 2. This is the t value. We'll put it in here, 2.898, and hit submit, and hopefully it works. A lot of times we do these to 2 or 3 decimal places. I will oftentimes just let Excel hold it here. Cautionary tale, as we do some of these, you might find some have a little bit of error. Feel free to message me if you think you got it. Please message me your work so I can see that, and then I can double check that. Just sometimes rounding gets a little weird with these, and sometimes it's important to kind of let more work be shown in it here. So I'm going to actually stop here with just the introduction and finding that critical t value. Stumbled through it here. We're going to, as a quick recap, we take our confidence level and our sample size. Our degrees of freedom is 1 less than our sample size. Alpha is 1 minus our confidence level, and then this tail area here in our picture, take alpha divided by 2, and then to find this t-score over here, 2.898. And again, the pictures are kind of rough things here. It's really to help us with the understanding. We're doing the t-inverse, and we're doing 1 minus this one to give us this whole probability to the left. These Excel functions in general just give us the area to the left, that kind of stuff. And so we're always inputting the area to the left here, and then this is the degrees of freedom, which we found here. Now I know some people are complaining about there being a lot of work to these. Feel free once you make these to like kind of copy and paste and then input new values. It's okay to do that as your work. You will be expected to generate from a clean sheet all of this stuff for the exam. So you do need to know how to do the process. Also, if you just have these numbers here and not these labels here, I have to kind of make some big leaps to know that you know what these things are. So please do a little work of labeling or keeping it organized just to so that if you happen to miss something, you can still get a lot of points for showing your work. So again, this is just the beginning of 6.1, doing confidence intervals with means. I'll be back with some more examples in the next video.